Again, this is the test scores program. Okay, and if we run this, it just simply takes 3 scores, adds them up, returns the total, and returns the average. So we do this quickly. We say run this module. And we'll enter 3 scores in, 75, 95, 85. It is simply adding them up and then dividing that total by 3 and returning that number. If we take a look at the script here, you should be able to understand all of this by now. We have these 4 print statements. This printing the welcome messages, a blank line, another welcome message, a banner. Then we are soliciting scores from the user. Note we are initializing total score to 0 before we do anything with it. This is a very good practice. And then we're using the compound operators here, compound addition. So every score that the user enters with an input gets added to total score. Down here, we're simply taking the final value of total score and we're dividing it by 3. I'm sorry. Yes, we are. We're dividing it by 3 and we're using round without an argument for the number of digits. So it's going to default the number of digits to nothing, no digits at all. It's going to, let's see what happens if we run it with an odd. Okay. And then it simply prints this banner and prints the total score and the average score and the values for each. Okay, so let's run this one more time and we'll try to make it so it doesn't add up right.
Are you looking for like a non-integer?
I am.
I think you have round in the average score.
Well, I do, but it should because I'm using round, right? This is the first argument to round, right? So that's just going to divide the total score by 3. But if that's an odd amount, it should come back with a real number, but it's not because I do not have an argument for round itself. Just bear with me. Let me try it one more time with 3 scores that don't add up right. There we go. So if you divide 88 by 3, what do you get? You get some odd number, but it's returning a whole number because round does not have a value for the remainder, right? This is, let me rewrite this. This is the first argument to round here. This is all I'm trying to show. If I want to round it to 2 digits, you have to add an additional argument at the end. And so let's run this. Okay, so I changed the round so it would round it to 2. Okay, let's take a look at your exercise and we'll move on to some more challenging material. Okay, so what do I have for your exercise here? Well, it's a version. Here, let me go into this. One thing Muroc does with his book, he posts the first 2 chapters as PDFs that are publicly available. So I included that. And here, if we go into your exercise folder for today, right, here's the 2nd chapter where a lot of this material came from. Now, near the end of this, he poses this exercise, which adds some functionality, asks you to add some functionality to the miles per gallon program. To save you a lot of time, I've included the starting program for this exercise 2.1, as well as the solution to it. And the solution to it is in your exercise folder. It says MPG solution. So let's call that up. Okay, so this is where you want to start when when you do your exercise for next week. You want to start from MPG solution, which is this one. And this basically does a couple extra things, does one extra thing, figures out the cost per mile. Notice it's rounding everything to 1. And let's run this real fast. Okay, so we run this module. You should start with this program. Enter miles driven, pick a number out of the air. 250. Gallons of gas used, we'll say 15. Enter cost per gallon, don't know, 355. Okay, so it simply computes miles per gallon, rounds it to 1 digit, total gas cost, again, 1 digit, cost per mile. And it's rounding that to 1 as well. So what do I ask you to do in this exercise? Well, let's take a look. So I ask you to modify that program to do a couple of things. I want you to switch back and forth between gallons and liters. And when you run the program, it should look something like this. You enter a name, it repeats it back. Similar to the solution, your starting solution, enter miles driven, gallons of gas used, cost per gallon. It should round everything to 2 digits. Also, however, you should convert the gallons into liters and print that out. You should convert the cost per gallon into cost per liter, print that out. Again, print out miles per gallon, total gas cost, cost per mile. And also additionally have asked the user to input any volume of liters and convert that into gallons. Okay, and so you have to do a couple of things to this. You have to be able to switch from gallons to liters. To help you do that, I give you the conversions here. 1 liquid gallon of gas is 3.7854 liters. 1 liter is equal to 0.264172 gallons of gasoline. Okay, so as always, I suggest the functions that you should use in the program to make it work. And these we've looked at quite a bit: print, input, float, round at a minimum. And then you have to calculate some numeric values for output, such as equivalent liters of gas, cost per liter, miles per gallon, cost per mile at a minimum. I want you to format it to make it all line up, look good like this. Notice again, the blue is output by the computer, black is input by the user. Here I itemize these requirements: 1, 2, 3, 4, 5, 6, 7, 8. You all probably are aware of this now, but what you should do is you should start with the solution file and then incrementally add each one of these capabilities to it, saving the new version with a new name, such as V1, V2, V3, and so forth. Okay, so here's another sample output. If you enter these same numbers, you should get the same output. Okay, so that's not too difficult. Now let's move ahead. We have some time left. So let's go into chapter 3, and I haven't given you these slides. Let's do this first. We'll look at a couple of programs that will be the focus of chapter 3. Then we'll start talking about the control statements that are demonstrated in the programs. Okay, so let's call this up. And actually, I think you have these programs in your day 2. You do. So if you go to programs for day 2, not sure if you do or not. Let's take a look. Yeah, you have this in there. Okay, so what does this thing do? Well, it does a number of things. Okay, let's run it. This is the invoice program. So it's asking for a customer type, and the choices are retail or wholesale. So we'll say this is a retail customer. It's going to compute a total, giving a discount, a different discount to either retail customers or wholesale customers. Let's say the total in this case is $750. If it's a retail customer with an invoice of $750, they get a 25% discount, giving them this discount amount in this new total to the invoice. Let's run it one more time, and we'll use a wholesale customer. We use the same numbers, invoice total $750. In the case of a wholesale customer, it gives them a 50% discount when the invoice total is $750, which is this much. So the new invoice total is $375. Okay, well, how are we doing this? We're using if, and we don't use while here, but we're using if-elif statements that determine the discount percent based on the type of customer and based on the amount of the invoice. Okay, so let's walk through this quickly, or maybe not so quickly. So here's the shebang line to start out. We printed a welcome message as we did before. This solicits input for the customer to be either retail R or wholesale W, customer type. And this solicits a numeric amount, a float for the total invoice. Okay, and then we use what's known as if-elif ladders to determine the discount amount, depending on whether it's retail, wholesale, or something else. Okay, so if-elif, we'll look at this more carefully probably next week, maybe in a few minutes if we get to it. So here they're not entering in anything. Here it tests the value of customer type, and we do a very minimal amount of data validation. Notice up here we're asking them to enter with a prompt. We're saying we want you to enter either an R or W. What does this do? What is lower? This is a method. Lower will change whatever the value is of this to a lowercase letter. So if they inadvertently enter a capital R or a capital W, this will change it to lowercase. Okay, so if it's a retail customer and invoice is in between 0 and 100, they don't get any discount. If it's a retail customer and the invoice is in between 100 and 250, they get a 10% discount. If it's a retail customer and the invoice is between 250 and 500, they get 20%. If it's more than 500 and they're retail, they get 25%. Okay, so this if-elif chain here just simply determines the discount amount for retail customers based on the amount of the invoice. With 500, anything greater than 500, they get 25% discount.